Welcome to quickcode.com. It starts with K, K-U-I-C-K-C-O-D.com. So today we are looking at put marbles in bag. You have bags. You are given a zero indexed integer array. Weights where like weights I is the weight of the ith marble. You are also given the integer K. Divide the marbles into the K bags according to the following rules. No bag is empty. If the ith marble and the jth marble are in a bag, then all marbles with an index between the ith and jth indices should also be in the same bag. If a bag contains all the marbles with an index from I to j inclusively, then the cost of the bag is the weights of I plus weights of j. The score after distributing the marble is sum of the costs of all the k bags. Return the difference between the minimum and maximum scores among the marble distributions. So basically the problem is given like an array of weights, right, and the k2, we have to split this array into two different parts or k different parts, right? So if k equals to 2, then there will be k minus 1 split, so there will be one split here, right? And for example 1 in one side and 3 5 1 in other side, and the weight of this one is the first element is 1 and the last element is also 1, so 1 plus 1, and the weight of this section is the first element, which is 3, and the last element, which is 1, so 3 plus 1, so total is 6. And similarly we can split in a different way, 1 and 3 on one side and 5 and 1 in the other side. And similarly we can take the weights, and the weight is 10, and we can prove that maximum weight is 10 and the minimum is 6, so max minus mean is 4, so 4 is the answer, right? So how can we solve it in a linear time constant, linear time? So basically let's take an example. Let's input be like a comma b comma c comma blah 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 up to j and k equals to 3, right? So note that we need to create k sub arrays, right? So we need to make k minus 1 cuts in the input array. So this is clear, right? Now let's say max comes from, say, from this partition, right? We first subarray will have one a comma b comma c, and the second subarray d comma e comma f, and the third subarray g comma h comma I comma j. So if this is the case, then what would be the weight? From here weight will be a plus c, so a plus c. From here the weight will be d plus f, d plus f. From here weight will be g plus j, g plus j, right? So this is equation 1. Similarly, let's say the mean comes from this arrangement, like say in one subarray which is containing only a, right? And the second subarray containing b c d e, and the third subarray containing f g h I j, right? So from here the first element is a, last element is a, so a plus a would be the weight, and the weight from here of this subarray will be b plus e, so b plus e, and the weight of this subarray is a plus j, so a plus j, and let's call it a second equation, right? So the answer is max minus mean. So answer is max, this is the max, and minus 2 is mean, right? Now note one thing here, it doesn't matter how you get the max, right? Max value, the first element and the last element will always be in the sum. So first element is a, last element is j, right? Similarly, no matter how you get the mean value, right, the first element and the last element of the array will be there. This is the a is the first element and j is the last element, right? A is the first element and j is the last element. So a is the first element and j is the last element. A is the first element and j is the last element. So first element and last element are always there in the max and mean, right? So therefore we can optimize a little more here. So therefore we can strike out the first element and the last element. So if we take this out, then we are left with c, right? So c, max is c, plus df and then take the G and exclude J, right? Only G. And the mean, so this is the mean, right? Mean, so we'll exclude A. We're left with A, right? And this is A. And then B plus E, B plus E, and F, we're excluding J, excluding the last element. So we got J, right? Now, rearrange. So C plus D, F and as F plus G, right? F and G. Similarly, so now you see we are getting a pair, like two pair, CD and FG. So look, arrange and note the is max coming from K minus 1 adjacent pairs. So CD are adjacent pair, right? And FG are adjacent pairs. So the max will always come from the adjacent pair sum. Similarly here, mean, right? Let's rearrange A plus B, so A plus B, right? And E plus F, EF. So this is adjacent pair, AB adjacent pair, EF adjacent pair. So the mean also coming from the adjacent pair sum, right? So um, then if you observe, then you can think that find it out that if we find all the adjacent pair sum and create an array, right, and then sort the array in ascending order, then the first k elements um, sum will be the mean value, and the last k element sum will be the max value, right? So we created the adjacent pair sum, right? Adjacent pair sum array. So this is the adjacent pair sum array. If we take this one as an example, this is the, if we take this as an example, then we are getting adjacent A plus B and the B plus C, at A plus B, B plus C, or comma D plus E, comma E plus F. So adjacent pair sum is here. So now sort in ascending order, and the max will be last k elements of the adjacent pair sum array, and mean will be the first k elements of the adjacent pair sum array. So the time complexity is n log n because we sort the array, right? And the space complexity is n because we create adjacent pair sum array, which will grow proportionally with the input array. And let's see the code. So first take the length of the weights array, right? And then adjacent pair array will be like n minus 1. Why? Because if you look here, let's take an example here, right? Input array A, B, C, D, 4, right? How many adjacent pair would be there? AB, AB, BC, BC, CD, CD. So this many, only 3 adjacent pairs can be done from the array of length 4. So the total adjacent pair is input array length minus 1. So this is the input array length, which is n and minus 1, and this many adjacent pair we can make, right? So now we are looping through this array whose size is n minus 1, right? And then we are creating adjacent pair from the weights. So weight I, right? Weights I plus weight I plus 1, and then we are putting it to adjacent pair sum array. So once we get this, we'll sort it in ascending order, right? And then we'll loop through this adjacent pair sum array, right? And now the answer is max minus mean. So the max will come from the last k pairs, and the mean will come from first k pairs, right? So we are taking element by element and subtracting it, and finally returning the answer. Yeah, that's it. So if you like it, please subscribe, and thank you very much. And you can submit here and execute, and if you submit, there are a number of test cases that will be executed on it, and if it all passes, then it will return success. And you can change the input here, like for example 3, and you can run it here. Thank you very much. Bye.